Okay, so these are going to be the examples for section 4.6 on the graphs of other trig functions. We're just going to be graphing the tangent function and then the reciprocals of our three trig functions. So there aren't any notes, we're just going to jump into examples. So we're going to look at the equation y equals tangent theta. And if you remember on the unit circle, tangent is the same as sine divided by cosine. So if you know all of the values around the unit circle for sine and cosine, then you should know the tangent values as well. So we're going to pick some angle values to plug in and then find out their tangent values, and then we'll plot those points to see what the graph looks like. Okay, so at 0 radians, the tangent is 0. Pi over 6, the tangent is square root of 3 over 3. Pi over 4, the tangent is 1. Pi over 3 is square root of 3. Pi over 2 is undefined because we're dividing by 0. 2 pi over 3 is negative square root of 3. 3 pi over 4 is negative 1. 5 pi over 6 is negative square root of 3 over 3. And pi is 0. So these will just give us a few points to plot just to start out. Okay, so what we're going to do is all of those fraction values or the square roots, we're going to go ahead and approximate those on the calculator just so we have a better idea of what they are equal to. So square root of 3 over 3 is about 0.58. Square root of 3 is 1.73. So this is negative 1.73 and then negative 0.58. Okay, so we're just going to start plotting points. So we're going to go 0, 0. Then we're going to go pi over 6, 0.58. Pi over 4, 1. Pi over 3, 1.73. Pi over 2 is undefined, and when we have undefined on a graph, that's going to be an asymptote. So we're going to draw a dotted line. So what's going to happen is this part of the graph is going to get closer and closer to the line, the asymptote, but it's never going to touch it. Okay, now on the other side of the asymptote, we have at 2 pi over 3, negative 1.73. At 3 pi over 4, we're at negative 1. 5 pi over 6 is negative 0.58. And then at pi, we're at 0. And what we're going to see from pi over, it's going to start the same pattern over again. So we can fill in those same points from that first section of the graph. And then at 3 pi over 2 on our unit circle, it's undefined again, so we would have another asymptote. Okay? And then our points would continue, like in the middle section. Okay, so this is what the graph of tangent looks like, and if I continue it on the left and the right, it's going to continue curving up in the same fashion. Okay, so when we're looking at these trig functions, remember we want to talk about their period and their amplitude. And the period is how often they repeat. Okay, so in this graph, the period is pi spaces. And the way to figure that out is if you find where two asymptotes are on the graph, you can subtract those x values. If you do 3 pi over 2 minus pi over 2, that will give you pi. That will tell you the period for this graph. Okay, then remember the amplitude is the height of the graph. Well, this graph is going to continue going up infinitely, so the amplitude is undefined for the tangent function. Okay, and so now we're going to look at the reciprocal functions. And remember, a reciprocal is when you take something and you put it 1 over that equation. So we're going to start with y equals cotangent x, which is the same as 1 over tangent. Okay, so we already have all of the values for tangent just on that previous equation, so we can use those values in this table as well. So we're going to use the same angle values, and then we're going to do 1 divided by the value that we got from the previous graph. So at 0 radians, 1 divided by 0 is going to be undefined. At pi over 6, 1 divided by the square root of 3 over 3 is equal to the square root of 3, and we know that's approximately 1.73. At pi over 4, that's 1 divided by 1, which is just 1. Pi over 3 is 1 divided by the square root of 3, which is square root of 3 over 3, which is approximately 0.58. Pi over 2, 1 divided by undefined. The reciprocal of undefined and 0, they are reciprocals of each other, so that is going to be 0. 2 pi over 3, 1 divided by negative square root of 3 is going to be negative 0.58. 3 pi over 4 is 1 divided by negative 1, so that's negative 1. 5 pi over 6, 1 divided by negative square root of 3 over 3, which will be approximately negative 1.73. And then at pi, 1 divided by 0 is undefined. So we have the same values for cotangent as we do for tangent, they're just in different places. Okay? So we're going to plot these points. So we're going to go 0 undefined. Whenever we have undefined, that's an asymptote. So there's going to be an asymptote through 0. Okay, then we're going to go pi over 6, 1.73. We're going to go pi over 4, 1. Pi over 3, 0.58. Pi over 2, 0. 2 pi over 3 is negative 0.58. 3 pi over 4, negative 1. 5 pi over 6, negative 1.73. And then at pi, we're undefined, so there's another asymptote. So you can see that this is going to continue this same pattern, and it's going to curve down and to the right. If I continued both directions, that's what it's going to look like. Again, the period is going to be pi. If I take and subtract the two asymptotes, pi minus 0 is going to give me pi. The amplitude is undefined again because it's going to continue going up infinitely. Okay, so now we're going to look at y equals secant theta, and we know that secant is the reciprocal of cosine. So we're going to have theta and then 1 divided by cosine. So we're going to start with 0, and that's going to be 1 divided by 1, which is 1. Pi over 6, 1 divided by the square root of 3 over 2 is approximately 1.15. Pi over 4 is 1 divided by square root of 2 over 2, which is approximately 1.41. Pi over 3, 1 divided by 1/2 will be 2. Pi over 2, 1 divided by 0 is undefined. 2 pi over 3, 1 divided by negative 1/2 will equal negative 2. 3 pi over 4, 1 divided by negative square root of 2 over 2 is approximately negative 1.41. 5 pi over 6, 1 divided by negative square root of 3 over 2 will be approximately negative 1.15. And at pi, 1 divided by negative 1 is negative 1. Okay, so now we're going to plot these points. So at 0, 1 is our first point. Pi over 6, 1.15. Pi over 4, 1.41. Pi over 3 is 2. Pi over 2 is undefined, so I'm going to have an asymptote. So it's going to get closer and closer to that graph. Okay, pi over 2, we just said is undefined. 2 pi over 3 is negative 2. 3 pi over 4 is negative 1.41. 5 pi over 6 is negative 1.15. Pi is negative 1. And if I continued filling in these angles, it's going to look something like this. We would have another asymptote at 3 pi over 2, and then it would continue on the other side. So if I went all the way around to 2 pi, these are all of those values, 1 divided by cosine. Okay, so if I fill those in, this is what the reciprocal of cosine looks like, which is secant. And it's going to continue on either side of those in the negative angle direction and past 2 pi again. Now notice here we could find the period. To find that, we could do 3 pi over 2 minus pi over 2. That's going to be pi. The amplitude is going to be undefined because it continues going up. I could actually graph the cosine function in between these curves, and they would touch at those maximum and minimum points. At 0, 1, that's normally where cosine starts, and then it comes down and back up, and at pi 0, it would cross again. So you could see that little curve, the cosine curve, waving in between the reciprocal. Okay, so now we're going to do the reciprocal of sine, which is cosecant. The same process. We're going to plug in the values of the angle and find 1 divided by sine. So 0, we've got 1 divided by 0 is undefined. Pi over 6, 1 divided by 1/2 is 2. Pi over 4, 1 divided by square root of 2 over 2 is equal to square root of 2, which is approximately 1.41. We're going to see the same numbers that we saw on the last function, since sine and cosine have the same values around the unit circle. They're just going to be at different angles. Okay, pi over 3 is 1 over the square root of 3 over 2, which is equal to 2 square root of 3 over 3, but that is approximately 1.15. Pi over 2, 1 divided by 1 is 1. 2 pi over 3, 1 divided by the square root of 3 over 2, which is approximately 1.15. 3 pi over 4, 1 divided by the square root of 2 over 2, which is about 1.41. 5 pi over 6, 1 divided by 1/2 will equal 2. And at pi, 1 divided by 0 is undefined. Okay, so we'll start plotting these points. So at 0, we're going to have an asymptote. Pi over 6 is equal to 2. Pi over 4, 1.41. Pi over 3, 1.15. Pi over 2 is 1. And then we're going to start seeing those values go back up. So 2 pi over 3 is 1.15. 3 pi over 4, 1.41. 5 pi over 6, 2. And then another asymptote at pi. If I continued on the other side of the unit circle, the points would actually be negative. And then we'd have another asymptote at 2 pi. Okay, so that's what sine looks like. Again, I could graph the sine curve in between here, and it's going to touch at the maximums and minimums, and then it's going to cross the x-axis at those asymptotes. Okay, so your homework is on page 339. You're doing 2 through 8, 12, 18, 20, 34, 36, and then 42 through 50 evens.